Hello, and welcome to Fibonacci Numbers by Tom Fry. Here we have the main sequence, well, the start of the main sequence for the Fibonacci numbers. It goes 1, 1, 2, 3, 5, 8, 13, and then 21. Or you could go 0, 1, 1, 2, 3, 5, 8, 13, 21. So, same but with a 0 at the beginning. Here we're just starting to go on to how to find the next term in the sequence of Fibonacci numbers. So, here it's F is the Fibonacci number, and then N is the numbering sequence. So for example, Fn, well, F1 is 1, F2 is 1, but F3 is 2, and show you why. Right, now this is how you work out the next term in the sequence. It's the number that you're on and the number for 4, add 2 numbers for 4. So if the number you're on is 3, then minus 1 is 2 and minus 2 is 1. So if you add Fn and Fn minus 1 and Fn minus 2, it equals Fn. And if you remember the sequence, 1 add 2 equals 3. Here we are going to show all the Fibonacci numbers, and we're going to do the Fibonacci numbers squared to find out another interesting pattern about the Fibonacci numbers. So obviously 1 squared equals 1, 2 squared is 4, 3 squared is 9, 5 squared is 25. Now I'm going to show you the real life implementations of the Fibonacci sequence, like petals on a flower. The Fibonacci sequence is kind of in tune with nature, because petals of a flower, most of them have a Fibonacci number as their number of petals, which is why you don't have a 4-leaf clover, because, well, you don't normally have a 4-leaf clover because it's not in the Fibonacci sequence. Here we have the Fibonacci sequence and the Fibonacci sequence squared underneath. What there is a pattern between the squared numbers and the normal numbers. So 1 add 1 equals 2, which is on the top. And also 1 add 4 equals 5, which is 2 across again. And the pattern carries on. So 4 add 9 equals 13, and so on. Now we have another interesting pattern with the Fibonacci numbers. If you add 3 or more of the bottom numbers, or you could have 1 of 1 is 2, and you keep on doing it in this pattern, then you get 6, 15, 40, 104, and so on. And if you look at the top row, that 6 equals 2 times 3, and then 15 equals 3 times 5. And then 40 equals 5 times 8. And the pattern continues like that. So yeah, now we're describing why. Now we are going to start drawing an example of how the Fibonacci sequence works, because it's probably the most easy method of doing so. So you start off with a 1 by 1 square, and another 1 by 1 square, and then 2 by 2 square, which makes a rectangle, and a 3 by 3 square, which makes a rectangle too, and a 5 by 5 square, which makes a rectangle, and an 8 by 8 square, and so on. So you can tell that there's a pattern somewhere. Now we have the same idea, but just a little bit smaller. So 1 by 1, 2 by 2, 3 by 3, and we're trying to work out the area. So what we do is 1 squared, add 1 squared, add 2 squared, add 3 squared, equals 15 squared. Now we are writing down the sequence underneath and showing how 3 times 5 equals 15.